Hello, Mr. Stone here, and today we're going to be talking about the area of triangles. And we've covered this before, way back in the day, right? The area of a triangle is 1/2 base times height, which is very nice, very convenient, very pretty. However, it doesn't always work. Why not? Well, it works, but it doesn't always work with the information that we've got. So, for example, what if we don't have the height? Quite often you don't see this in a non-right triangle. In a right triangle, it's very nice because you've got your height is like right there. You can use that as your height. It's perfect, or vice versa. It's very convenient because they're perpendicular to each other. But we don't see that here. So what can we do? Well, we can use some trigonometry and basically find that height for us using this formula. The area of a, let me make that sub t for a triangle, is equal to 1/2, like we had before, AB times the sine of big C. And let's get a little bit into the nomenclature here of how we're going to be labeling in our sides. Quite often when you're working with triangles and trigonometry, it's convenient to name the vertices of the triangle capital A, capital B, capital C, or as I like to say, big A, big B, and big C. The sides that are across from that would be the little version of that. So across from big A is little a, across from big B is little b, and across from big C is, little c, which is a little bit tougher to see because capital C and lowercase c aren't that different. But, so now, let me change color here. Now, what we really want here is the height. And this is why this formula works. If you look at the relationship between this new triangle here in red. We don't know what this is down there. Honestly, right now, don't care. What is interesting is the opposite side from angle C is our height of what that triangle would be, because you've got a right angle there. The base is perpendicular to that height. That's what we want. That's the height that we need. So how do we get this? Well, if you look at sine of big C, that's equal to your opposite, and just for simplicity's sake, let's call that x, opposite over hypotenuse, which is b. Well, we know what b is, because we were given that. That was the part of the information that we're working off of. If we want to get the height of that, then that would we'd just get b the other side there by multiplying both sides. So b, little b times sine of big C is equal to x. Okay? Maybe I should have named it h, because that really is our height. So if we look back here, this is actually our height. And hey, what do you know, if we treat A as the base? I know the letters get a little bit confusing, but in our original example up above, or the formula we've been working with for years, is they decided to call this little b, and for base times height times 1/2, that's what we've been working with for years. Okay? That's why it works. Aha! Aha, you are saying, but what about that case where I've got something like this, where I can't really see that height too well? This is still my base, and I don't think this would work. Well, let's check it out. If we extend a new triangle here, this is that height that we want, right? And now we're working with this angle right here. Here's the angle that we're given. Let's just call it theta. Okay? This new angle right there is simply 180 minus theta. Your whole line right there is going to be 180 degrees, right? So we're still working with sine of theta, but we've got excuse me, we're not working with sine of theta just yet, but we are, and here's why. We're working with sine of 180 minus theta. Now, if you think back to your unit circle, let's look at the angle 120 here for a moment. So if I take the sine of 120 degrees, that's going to give me my height. of that, right? Because that is your y. And if we, oh, pardon me, if we look at if we look at our height right there, our coordinate, it's negative 1/2 square root of 3 over 2. Okay? That's height. Go over here, and if we look at this side, it's 1/2 square root of 3 over 2. Whoop, that's a 2. These are the same because it is the same height. That is your sine. So the sine of 120 is equal to the sine of 60. Interesting. What's even more interesting is that basically what we're saying here, and we can prove this in more depth just by looking at the unit circle, but the sine of 120 is equal to the sine of 180 minus 120, or more generally, the sine of theta is equal to the sine of 180 minus theta when you're talking in degrees. So that's just a little bit about why this works. And it will work in this case too. So no matter where you're at, you can go back to this formula here, and it will give you the area of any triangle, provided you've got the necessary information. And in the event that you've got, sorry, I'm jumping all around here. In the event that you've got, let's say you've got C and you've got A, you can just swap things around. So now your area of that triangle is going to be, if you're given B, so you're going to use sine of B times 1/2 A times C. They're interchangeable. I mean, it's just different naming. We could rename everything so that it fits whatever we've got. Let's look lastly here at our an example of seeing this in use. This is how you will use this. So let's say I've got a triangle here. I've got two sides I'm given, and I'm given the angle that is between those two sides. Just area of your triangle, just plug that on in. 1/2 of 20 times 17, let's be, times the sine of 50. That's 50, not 56. If you go to your calculator, you'll get, we can simplify that. That's just 10, 17, sine 50. And remember that this right here, the 17 sine 50, that's your height, because it's the sine of 50 is equal to your opposite h over 17. 17 sine of 50 is equal to your height. Clean all that up, and then you get about 130.2. That's the area. Alright, review that. This is the formula one more time, and its other variations would be equals 1/2 AB. The other variation, I'm sorry, we already have that one. BC sine A, that's the other variation, and our original of 1/2 AB sine C. They're all the same, just different naming. Review that, bring in any questions if you've got them, and carry on. Have a great day.